So in this video, we are going to find out what eigenvalue and eigenvector for 3 cross 3 matrix. That means 3 rows and 3 columns will be there. So A is a given matrix. We have to find the eigenvalue and eigenvector. So first, how to find the eigenvalue? The first thing, we have to find the characteristic equation. After finding the characteristic equation, solving that characteristic equation, we will be getting eigenvalue. Solving that eigenvalue, we will be getting the eigenvector corresponding to each eigenvalue. Let us first find out the characteristic equation. Now here we are having two ways to find out the characteristic equation. First way is the traditional method by using the formula of what? Determinant A minus lambda I equal towards 0. Equating to 0, you will get one characteristic equation, and here A is the matrix given in the question, lambda is the eigenvalue, I is the identity matrix which is of the form of same form, that means 3 cross 3 means it also will be 3 cross 3. Okay, second method is formula based method. Okay, that is equal to what? Lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This is the form. Now in which you have to understand what is s1, s2, s3 and all. Okay, that is important. So if you observe over here, the S1 value is basically what? The sum of main diagonal elements. Diagonal elements, for example, here if you observe, the diagonal elements are nothing but this part, right? 1, 5, 1, you have to add them up, you will get S1. S2 is the sum of minor of diagonal elements. You might have studied in the lower classes, minor and cofactor. So we are here, we have to deal with the minor diagonal elements only we have to consider, not the entire matrix. Then sum of that. Then third one is S3, which is the determinant of A. So first method says what? A minus lambda I. So I have taken the A matrix, okay. Then I have to subtract lambda, then multiply with this one. So we'll see what happens here. So minus lambda is the, then I matrix is also the same form, 3 cross 3 I have to take. It will be 1 0 0 0 1 0, then 0 0 1, it will be this form. Okay, this is also 3 cross 3. Now after writing this, we have to equate it to 0. That I will write afterwards, because I have to take determinant. Here I have taken just the matrix form. Now what happens over here is that lambda, if you multiply inside the bracket, inside the matrix, it basically means what? Each and every element you have to multiply with lambda. So 0, if you do the multiplication, it will be 0. It will remain 0, and 1 1 1, this only will change. So we have to change this lambda, multiply inside. This 1 1 1 will change into what? Lambda, lambda and lambda. That's it. Now we have to just subtract these both. So corresponding element I have to subtract. That means 1 has to be subtracted with lambda, 1 has to be subtracted with 0. Corresponding elements, I hope you know subtraction of matrices. So what will happen over here? 1 minus lambda, then 1 3 1 5 minus lambda, then 1 3 1 1 minus lambda. So what's the meaning of this? That if you do directly also, you will get this matrix. So basically what you have to do, just the whatever A matrix is there, that particular diagonal elements, you have to just subtract what? Lambda. That's it. Okay, rest all will remain same. So this particular matrix, we have to take the determinant, equate it to 0, right? So I'm going to take the determinant of this. And equate it to what? 0. So I'll expand through what? First row. You can take first row, first column, second row, second column, anything is fine. But I am going with what? First row. So first row, if you consider, the first element is given over here. Okay, this particular element row and column, what is left out? This particular thing, I have to take the determinant. So what happens here? 1 minus lambda into, then 5 minus lambda into 1 minus lambda, minus what happens? 1 into 1, that is minus 1. Okay, done. Next element, whenever you're taking the second element, it should be always with negative sign. So minus 1 it will become. Okay, now remove this row and column. What is left out? This particular thing and this particular thing. Take the determinant of that. 1 into 1 minus lambda. So 1 into 1 minus lambda is nothing but 1 minus lambda itself. And minus, now what you have to multiply? This 3 into 1, which is 3. Then next part is that plus 3 outer, right? Okay, plus 3, the last element. Remove this row and column. So what happens over here? 1 minus 1 into 1 is 1, minus of 3 into 5 minus lambda. So 1 minus 3 into 5 minus lambda. Okay, equate it to 0. This is what we are going to do. Now we are going to do the simplification part in a fast forward way. Okay. Next we'll go for the second method. We have got here the equation. Now second method also we should get the same equation, right? So we'll see the second method how much time we are taking to find out the answer. Let us try to understand that also. This is the formula should be applied. S1, S2, S3 we have to find it. Let's start with S1. S1 is the sum of diagonal elements. So S1 is sum of diagonal elements, that is 1 plus 5 plus 1, which is equal to 7. Next, S2 value will become what? Sum of minor of diagonal elements. So how to find out that? Very important. So, okay. See, let us try to understand that minor. So first diagonal element is 1. Okay. So how to find minor? Leave this row and column wherever 1 is sitting. So what is left out? This particular we have to take the determinant. So it is 1, 5, 1, 1, 1 column wise. Okay. So it will be 5, 1, 1, 1 plus sum, right? Next. Second diagonal element you have to take. Leave this row and column wherever the second diagonal element is sitting, and whatever is left out form the determinant. So 1, 3, 3, 1. So it will be 1, 3, 3, 1. Next, add the third diagonal element. Leave this row and column. Now what is left out? This particular thing. Determinant you have to write 1, 1, 1, 5. Okay, done. Now we have to find the determinant. Multiply 5 into 1, 5, minus 1 into 1, 1, plus 1 into 1, 1, minus 3 into 3, 9, plus 1 into 5, 5, minus 1 into 1, 1. So how much we are getting? 5 minus 1 is 4. This is minus 8 plus 4 is equal to what? Minus 8 plus 8 is what? 0. We are getting 0. Okay. Next, S3 we have to find out, which is the determinant of A. So determinant how to find? I'll expand through what? Row, first row itself. So what will happen? First row is sitting over here, right? First row. So first one I'll take. So 1 into, eliminate this row and column, take the determinant of this. So let me just write, that is equal to 1 into 5 into 1 is 5, minus 1 into 1 is 1. Next, the second element, whenever you are taking, you have to take minus. Now see over here, second element in first row is this one, 1. So I would write first 1. Then eliminate this row and column. What is left out? 1, 3, 1, 1. Take the determinant. How to take the determinant? 1 into 1, that is 1, minus 3 into 1, 3. It will be 1 minus 3. Third element with positive sign, that is 3. So eliminate this row and column. See, there is a difference between minor and this thing. Don't get confused. Okay, determinant we have to consider this element also. In my minor thing, we didn't consider the elements. Be careful with that. So here, eliminate this row and column. Take the determinant of this thing. So it will be 1 into 1, 1, minus 3 into 5 is 15. So 1 minus 15. So the simplified version will be 4 plus 2 minus 42, because minus 14 into 3 is minus 42, equal to how much we are getting? Minus 36, right? Now we have to write the put it in the equation. So what will happen? Lambda cube minus s1, so minus 7 lambda square plus s2. S2 value is 0, so no need to write. Proceed with next one, that is minus 36. Here minus again one more sign is there, right? So it will become plus 36 equal to 0. Now you observe this value and this value, whether they are same or not. They are exactly same. Now you have to decide which one we are going to apply. You are going to apply whether this second method or the first method. Anyways, you are getting the same characteristic equation. Okay, fine. Let us proceed with the second step of the procedure. Going for the second step, where after getting the characteristic equation, that is lambda cube minus 7 lambda square plus 36 equal to 0, we have to find what? We have to find the lambda value. For that, we have to simplify this equation. Now here simplification of this equation can be use the calculator if it is allowed. Otherwise, we have to go by synthetic division method. That is a new concept we are going to learn. Very important concept. Whenever more than quadratic equation, no need to apply synthetic division. Direct factorization we can do. But more than that, cubic equation, beyond that we can apply synthetic division. How to apply? Let us see. The first thing, right here the coefficients of whatever the terms are there, okay, in descending order. That means coefficients in the sense lambda cube is the highest power, write the coefficient as 1. Next is lambda square minus 7. Next is lambda, but lambda is not there, you have to write it as 0. Very important step. Then last term is 36, write 36 constant term, right? Done. Below the first element always it is 0, that you leave. And next, very important step is that in synthetic division, we have to go by what? Inspection method. Inspection method in the sense, we have to find one of the roots. How many roots will be there for this equation? How many values of lambda will be there? 3 values, since it is cubic equation. One of the root we have to get by inspection method. So, in place of lambda, apply plus 1 minus 1, plus 2 minus 2, plus 3 minus 3, and so on. You keep on applying, where in place of lambda you substitute. When you substitute on the LHS part, if you are getting RHS value as 0, then it is one of the root. Simple concept. So, for example, here if I apply lambda value as minus 2, you have to come from 1, minus 1, 2, minus 2, like that, so on. Okay. So, when I apply minus 2, what will happen? Minus 2 power 3 minus 7 into minus 2 square plus 36 equal to how much? I don't know. So, don't put equal to 0. Okay. So, minus 2 cube. 2 cube is what? 8. Minus this thing will be minus 8. Okay. Then minus 7 into minus 2 square is 4 plus 36. So how much you are getting? Minus 8 minus 28 plus 36. So it is minus 36 plus 36 equal to 0. So when you got equal to 0, that means this particular lambda value is minus 2. That is one of the root. Okay. So you have to go by inspection method. This is called as inspection method. You have to apply and see. 1 minus 1, 2 minus 2. So when I reached minus 2, I got this value. So I will apply here minus 2. Put it over here, whatever the root you got. Now here 1 is sitting. 1 plus 0 you have to do. It is always the same number. Yeah. It is this 0 is fixed. Okay, all the problems you have to put 0 there. Now minus 2 into 1. Right below the next number. Minus 2 into 1. It is minus 2. Add both. Minus 2 minus 7 is minus 9. Next, multiply minus 2 and minus 9 right below the next number. So it is plus 18. Add both. So what will happen? We are getting it as what? 18. Done. Minus 2 into 18 you have to do. Right below the next number. It is minus 36. Add both. You are getting 0. Always remember the last value after adding you should get 0. Because you already know that this is one of the root. So directly you should get 0. Now why we are doing this then if you are getting 0? Because we have to find out the other two values of lambda. For that we need this part. Okay. Otherwise one more method is that instead of going by inspection method, you can directly put over here the roots and check. If you are getting 0 over here, then you have to understand that it is one of the root. So what, here we had what? Lambda cube, lambda square, lambda, then the constant value, right? So decrease one power, that will become lambda square. So the 1 will be the coefficient of lambda square. next again lambda, next the constant part. Okay, this is the way to write the equation coming from here. Okay, what will happen? 1 lambda square minus 9 lambda plus 18 equal to 0. This is the equation form. This is a quadratic equation. Okay, so decrease one power, write it in this form. After writing, we have to get the value from here. We can apply the calculator again if it's allowed, otherwise anyways, if you have done the synthetic division without the calculator, you have to do this equation also without the calculator. Simple thing. So here quadratic equation can be solved using what factorization method, splitting a middle term. Quadratic formula also you can apply. So I will basically prefer what splitting a middle term. So I have to split the middle term. So 1 into 18 is what? 18, and minus 9 is the term sitting. So when I add, I should get what? Minus 9. When I multiply, I should get 18. Two numbers I should have. So 18 factors I'll take 1 and 18, 2 and 9. Okay, 2 nines are 18. Then what we are getting? 3 6 are 18. See here, 3 and 6 if I take, I can get minus 9. Yes, you can get. So I'll take here minus 3 and minus 6. Why? Because when I multiply minus 3 into minus 6, I'll get minus plus 18, plus 18. And when I add minus 3 minus 6, it will be minus 9. So I'm getting the value. Now here the simplified version I'll write here. So lambda square minus 3 lambda minus 6 lambda plus 18 is equal to 0. Grouping of first two and last two, take lambda outside, lambda minus 3. Here also lambda minus 3 should be outside, equal to 0. So what should be sitting outside? It will be minus 6, right? So lambda minus 3 common, and what is left out? Lambda minus 6 equal to 0. So here we have got the multiplication factor. So that means we can write lambda minus 3 is equal to 0 and lambda minus 6 is equal to 0. So from this lambda value will be 3, from this lambda value will be 6. Done part. Lambda is equal to minus 2, 3 and 6. Minus 2 we got it from here using the inspection method, right? So same thing can be applied here. Okay. So we are going for this step 3. So after finding out the eigenvalues, we got 3 eigenvalues. One is 2, minus 2, sorry, minus 2, 3 and 6, right? 3 eigenvalues. Corresponding eigenvectors we have to find. What is the procedure? So you have to remember A minus lambda I into X matrix is equal to what? The 0 matrix, okay, of the form, same form. Now here A minus lambda I we already know, which we found out earlier also. So let us see that first. Okay, so this particular thing is A minus lambda I. Then multiply with the X matrix. X matrix is nothing but the eigenvector matrix. So it will have three variables, three unknown variables, okay. So here we'll be having X, Y and Z, 3 cross 3, that's why. Equal to 0 matrix, also same thing, 0 0 0, close it. This is 3 cross 1, this is also 3 cross 1. Done that part. Now we have to form the equation, right? So starting with the eigenvalue, I'm going to take minus 2. We are going to find out the answer for that. So when I apply, instead of lambda minus 2, what will happen? 1 minus of minus 2, it will become what? 3. So I have to write 3, then 1, then 3 as it is, 1. Then 5 minus of minus 2, it will become 5 plus 2, 7. Then here 1, then 3, 1. 1 minus of minus 2, it will become 1 plus 2, 3. Then the X matrix will remain as it is. Now we have to form the equation. So three equations will be formed over here. So first equation will be when you multiply the first row with the column equal to 0, the first equation. Second row with the second column, column, it will become the second equation. Third row with the column, again it will become the third equation. So three equations. Now three equations are formed over here. You can observe that first and third equation are exactly same. So now we are not going to apply their what cross multiplication method. So we are going to take one or two or three. Anything is fine. If you take any of the equations, two equations, you will be getting the same answer. So we are going to apply what cross multiplication method. X, Y, Z. Below x, y, z, I'm going to take 1 and 2 equations. You can take 2 or 3. 1 and 3 no need to take because exactly same equation is there, right? So just write the coefficients below that. First equation coefficient will be 3, 1, 3. Second equation coefficient is 1, 7, 1, right? After this, very important step, write x by equal to y divided by equal to z divided by. Okay. Now x divided by how to write? So eliminate this x part. C on the right side. Whatever is there, take the determinant of that. So it will be 1731. Done. Next, coming to y part. Here also same thing. Eliminate this y term, whatever is there. C on the right side. 1 3 is sitting. So I have to write first 1 3. And whatever is left out. Left out in the sense, again if you come back, it will be x terms. So it will be below x whatever is there. So 3 1 again. Next. Z value below that we have to write. Eliminate this z. C on the right side. Right side known is that again I will come back to x term. It will be 3 1 and y term which is 1 and 7. This is how you have to write. Some of the textbook might use here minus sign. Okay. Why they are using minus sign? Because I will tell you. The y term when you eliminate, they are taking from left to right combination. That means they are writing 3 1. Then after that they are writing 3 1. But what I said, I am seeing on the right side itself. Right side in the sense only right side I am seeing. I am not going with what left right combination. Okay, so that's why they have taken minus sign. This is more preferable, you can say, because here we can see the pattern over here. This and this will be same, this and this will be same, and this will be exactly same. So you can understand whether you have done wrong or not. Okay, so here it is better to take y coefficient as plus 1. So it will become x divided by, now 1 into 1 is 1 minus 7 into 3 is what 21 equal to y divided by 3 into 1 is 3 minus 1 into 3 is what 3 equal to z divided by 3 into 7 is what 21 minus 1 into 1 is what 1. So how much you are getting? X divided by minus 20 equal to y divided by 0 equal to z divided by how much you are getting here? 20 again. Okay. Now here cancellation can be done. 21s are 21s are. So what is the left out term? We can say here x divided by minus 1 equal to y divided by 0 equal to z divided by 1. Okay. So whatever is there below this x y z, that will be the vector. So x y z, the vector will be equal to eigenvector minus 1, 0 and 1. And this is corresponding to lambda value minus 2. Done. Next we have to find out two more eigenvectors. Now we'll go with the lambda value of 3. Okay. So lambda value I'm going to take 3. So let us see what happens over here. So 1 minus 3 is minus 2. So minus 2, 1, 3. Then 1. Then 5 minus 3 is how much? 2. So it will be 2, 1, 3, 1. 1 minus 3 is how much? Minus 2. Write the equation. So how to write the equation? Quite simple. We have to do the multiplication. So first row into this column equal to 0. Second row into this column equal to 0. Then third row into this column equal to 0. So three equations will be formed. So any two equation you can take and solve this one. So I'm going to take fourth and fifth. Okay, anything is fine. Any equation you will be taking, you will be getting the same answer. Okay, you can try that once. So cross multiplication method, as I said, what you have to do? X, Y, Z. So below x, y, z, write the coefficients. Fourth equation coefficient I'll write first, then third equation coefficient. After that, what you have to do? X divided by equal to y divided by equal to z divided by. This is what you have to do. Okay. So how to do that? So eliminate this x part is the eliminate this x part, see on the right side. So whatever is there left out part, that you have to take the 2 cross to determine. Okay. So it is left out part is 1, 2, 3, 1. Coming to y part, y you eliminate, see on the right side. So 3 1 is sitting and minus 2 1 is sitting. So it will be 3 1 minus 2 1. Then z part, eliminate this part, see on the right side. So coming back, we have to write x first then y. Now we have to do the cross multiplication. What happens here? 1 into this thing we'll find out. So 1 into 1 is 1 minus 2 into 3 is 6 equal to y divided by 3 into 1 3 minus 1 into minus 2 is minus 2, so it will become plus 2 equal to z divided by minus 2 into 4 is minus 4 minus 1 into 1 is 1. So how much we are getting the value? X divided by minus 5 equal to y divided by 5 equal to z divided by minus 5. So you can cancel with 5. 5 ones are 5 ones are 5 ones are. So what is the remaining term? X by minus 1 equal to y by 1 equal to z divided by 1. So x, y and z, the eigenvector value will be equal to minus 1, 1, 1. This is the eigenvector corresponding to lambda value what? 3. So here I am going to find out the last eigenvector. The lambda value will be equal to what? 6. So I am going to find out that. So matrix will be formed 1 minus lambda. So 1 minus 6 is minus 5. Rest all terms will remain same in the first row. Then second row 1. 5 minus 6 is what? Minus 1. Then 1, 3, 1. Then 1 minus 6 is minus 5. After this, the equation, three equations will be formed. So first row into this column equal to 0. Second row into this column equal to 0. Then third row into this column equal to 0. Okay. So any two equations I can take. So here I will take the 7th and 8th equation. So cross multiplication method we have to apply over here, right? So x, y, z. So below x, write the coefficients. It will be minus 5, 1, 3, and next is 8th equation coefficient 1, minus 1, and 1. Okay. Now you have to write x divided by equal to y divided by equal to z divided by. Okay. So matrix form will be there. So how to calculate that? Eliminate this x value. See on the right side. So two parts are there. Write 2 cross to determinant. 1 minus 1, 3 and 1. Then below y what will happen? Eliminate this y. See on the right side. 3 1 is there. Then again come back. Minus 5 1 is there. Then z value you eliminate. See on the right side. Who is sitting? Minus 5 1, 1 minus 1. Now you do the multiplication part. So determines what will happen? X divided by. So 1 into 1 is 1 minus. Minus 1 into 3 is minus 3. So it will become plus 3 equal to y divided by 3 into 1 is 3 minus 1 into minus 5 is plus 5. It will become plus 5, right? Plus 5 equal to z divided by, it will become 5 minus 1. X divided by 4 equal to y divided by 8 equal to z divided by 4. Okay, so 4 ones are 4 twos are 4 ones are. So here 1, 2 and 1 we got. So x by 1 we got, y by 2 we got, and z by 1 we got. Okay, so whatever is there below this one, that will make the eigen vector. So it will be 1 2 1. So this will be the corresponding eigenvector for the eigenvalue lambda is equal to 6.